Good afternoon, students. Welcome to my channel, Maths Easy Mathematically Fluent. Today I am going to explain the concept of inverse function. What is inverse function? How to find the inverse of given function and how to draw a graph. Suppose if the graph is given, how can you say that whether inverse is existing or not? So we'll check it out with all those things. Okay. Now see here. Inverse function. Inverse function means suppose f maps a to b is a function. Okay, f inverse is b to a. Its inverse will be b to a. So if f of x is a function, if f inverse exists, means it must be a one onto function. If it is a bisective, then inverse exists. If f is a bisective, 1, 1 and onto, then we can say that f inverse exists. Okay, and the domain of f is equals to the range of f inverse, and the range of f is equals to the domain of f inverse. Okay, now. So generally, what we can say that is by this we can say that domain of f is equals to codomain of f inverse, and the codomain of f is equals to the domain of f inverse. Okay, this is the f inverse of that. Suppose if you write generally, if we write the coordinate form order pair means suppose like f is equals to 1 comma a and 2 comma b is given like this. So f inverse what we can write over here. So we should interchange the elements coordinates. So a comma 1 and b comma 2, that is inverse of a function. It's clear on that. Now see here inverse function. Suppose this is sin x graph is given like this is there. Okay, this is 0, here 1, here minus 1. Okay, this is minus 1 also. So this is pi by 2, sin pi by 2 is 1, sin pi is 0, sin 3 pi by 2 minus 1 like this. So inverse of this function, so domain will become here codomains. So how it will be inverse of the function will be, it will come like this. The graph will be like this, inverse of a sin x graph this is. So this will be the sin inverse x graph. Okay now. So we passing to the origin only. Okay now, that curve will be like this. The domain will become range will become domain over here. Okay, this is we can draw like this. Suppose see here and see if f of x is equals to f inverse x, then we can say that f is called as self inverse function. Okay, now if it is a self inverse function means the graphs of f and f inverse are reflections of each other in the line y is equal to x. Okay, reflection in each other in the line y is equals to x. Suppose this is like for example the curve I am drawing like this. Okay, whatever it may be. If it is like this, the curve is going on like this. It is symmetric about the y is equals to x axis. So the inverse function will come like this. Inverse of that. Okay now. So this curve is f of x here. So this is f of x. This will be the f inverse x. If f inverse x is equals to f of x, then we can say that this is self-inverse function, and these two functions are reflections of each other in the line y is equals to x. You remember that point. Okay now. So based on this, we will see some examples over here. See. Okay. See here, on a copy of each grid, draw the graph of f inverse if it exists. Okay now. Suppose see here, already I told you. See, it is if you draw the graph over here, this F inverse function will be okay. So how will you draw this one? See here. So the line is, this is given line. Okay, let me change this. This is a given line. Same, you should draw same line. So we are intersecting here. Suppose if we are assume over here, okay, and it will be over here in between 1 and 2, minus 1 and 2, here 1 and 2. It is like that. Okay, now it is symmetric about the y is equals to x, y is equal to x, 2x, whatever it may be, that is. So we should draw the diagram. Okay, now like this. If it is passing through the origin, okay, but it is y is equal to x only, we cannot say. If y is equal to x means f is equal to f inverse x, then only we can say that it is reflection each other in the line y is equal to x. We have maybe it is y is equals to 2x, maybe y is equals to 3x, like that. It is depending on that. Okay, now suppose if this function is equals to this inverse function is, then we can say that that is self inverse function. Okay, now we have to draw F inverse only. We are not considering over here whether it is self inverse function or not. Okay, now see here. Next, suppose the graph is given like this. So symmetric, you should draw like this diagram. Where it is intersecting, you should go like in that way only. See, okay, here 4 is there over here on y-axis. Here also on y-axis, it should come like this. Okay, now it should come like this over here. Okay, so this is how we have to draw. In the same way, the curve is given like this. Now, if it is symmetric about this line means you should draw the line will be like this. Okay, now so it is, see, the curve is given like this. Once again, I am drawing over there. Like this is given. So then it will come like this somewhere over here. Okay, now so you should draw clearly over here. Now see here. Suppose, and in these three cases we have drawn F inverse function, but in this case we are not going to draw. Why? Because see, generally when the F inverse exists means if it is a 1 and onto function. 1 function means if I am drawing any line parallel to x-axis, that line should intersect the given line at one point. Suppose first line only is here. This one is there. If I am drawing a line which is parallel to x-axis, it is intersecting at one point. So then only we can draw the graph of F inverse x. In this also, if you draw a line, parallel line, so intersecting at one point only. Here also draw one line. If this also intersecting at one point only. Okay. Suppose if you are drawing a line over here, see here, intersecting two different points. Two different points means it is not one function, so we cannot say that inverse exists. So inverse F inverse x does not exist over here in this case. Is it clear? So if you draw the diagram, we can understand. Okay. Next, see some problems we'll see over here. How to find F inverse x? I have taken some questions over here. We'll see. Okay. See, f of x is given x by 7 by x plus 2 for x belongs to 1 and x does not belongs to, means not equals to minus 2. Why not equals to minus 2? If x is equals to minus 2, this function is not defined. Okay, now that's why they have given condition this. Is it clear? Now, say here. So what I am doing, f of x, whatever it may be, for all the problems, you should do the same process. Let us assume y is equals to f of x. F you send this side. F if you send that side, what do you get over here? F inverse y. Okay, now. So just keep it, this is equation 1 like that. So we assumed f of x is equals to y. So y is equals to this whole part. So what will you get over here? And simplify that and make x as a subject. 7 minus 2 by the y minus. But what is the x value over here? X is equals to f inverse y. F inverse y you write down over here. Okay, now. So this you will get over here. So just you change the variable. Interchange the variables means changing variables. F inverse x is equals to 7 minus 2x by x minus 1. Okay, this is how we have to simplify the problem for finding the F inverse x. Okay, now let us do some more another problem. See here, f max extends to x square plus 4x for x belongs to R and x greater than or equals to minus 2. State the domain and range of F inverse. So domain and range of F inverse means, so what it is, F range will be domain of F inverse, F domain will be range of F inverse. Okay. So find expression F inverse X also. Okay, that's fine. See here, F of X is equals to this one. And I clearly mentioned that the domain part is X greater than or equals to minus 2. Domain of F of X is greater than or equals to minus 2. Okay, now just keep it like that. First we'll find the F dash of X over here. Okay, first we'll find the F domain and codomain over here. Okay, F of X is equals to this. First we convert into standard form, perfect square form, like a into x plus b h whole square plus k. That form we are converting. Already we have discussed this one in the last class. Okay. So f of x is this, if you are adding and subtracting over here, plus and minus 4. So this will become what it is over here, x plus 2 whole square minus 4. So minus 4, x plus 2 whole square minus 4 means this function will be minus 4 above only. So the range of f of x will be minus 4 above only. Above values will get over here. So domain of f inverse x will be what it is over here, the range of f of x. So minus 4 to infinity. The range of f inverse x is what it is over here, the domain of f of x, minus 2 to infinity. Okay, so now I am going to find the f inverse x over here. So similarly what we have done here, same thing we can do over here. Y is equals to x square plus 4x. Then is simplified. You convert into in terms of x only. X is equals to this. Okay, so and you will ask one question over here. You will have one question. X plus 2 is equals to square root is there. Square root is maybe plus or minus y plus 4 we will get. So that is what we have. If I take minus over here, minus 2 minus how much over here? So both are negative value, but if the values will be what it is over here, minus 2 above values. Above values means minus 2, minus 1, 0 like that. So that's it. We are avoiding minus symbol. So plus symbol we have to consider. So f inverse y is equals to this one. We change the variables, f inverse x is this one. Is it clear? Now, next question is here. And G maps extends to x square minus 8x plus 10 for x belongs to R, x is greater than 3. So domain part is given x greater than 3. Explain why G has inverse. Okay, why it has inverse means we have to mention. Okay, now see here. Why it has mentioned, see, find an expression G inverse x also. Already I told you f inverse exists when you draw a line parallel to y-axis. It should touch at one point only. At the vertex, it is touching what one point only. At this point, we will get the inverse. Inverse exists over here. So see here, when you draw this diagram, this is a parabola. So parabola means see here, you will get this like this, which is not intersecting on. First, if you convert into a into x minus h whole square plus b, means vertex will be 2, 2. This will be 2, 2. The curve will be like this. So okay, now the curve, it is not intersecting x-axis also. So I am drawing a line parallel to this. It is touching the curve at one point only. So we can say that inverse exists over here. So the first part is completed. Okay, now. So now the vertex will be 2, 2. Since it has vertex, then g of x is 1, 1. So it has inverse exists over here. If it is inverse exists over here, means you have to simplify it. This you take, let us assume this y is equals to this part. And simplify x is equals to, you will get this 2 plus root of y plus 2 by 2. So then you change the variable f inverse x, you will get it. Okay, now. So this is how we have to simplify the problem for finding the f inverse x. Is it clear enough? Okay, students.